Hi there. Today I'm here with Luca Mezzalira. He is a principal serverless solutions architect at AWS. He's also an O'Reilly author, and he's also a conference speaker. He's also the inventor of Microfrontends, if it's fair to say that. And I'm very excited to talk to you, Luca. How's it going?
All good. Thank you very much for having me. It's a pleasure being part of this podcast.
Yeah, thank you. Could you give us like a brief introduction on yourself and what you're doing at AWS?
Yeah, sure. So in AWS, I'm a serverless specialist solution architect. So basically, the specialist team are the ones that usually work in conjunction with customers as well as service teams. So each of us has a specialty. So we cover a subset of our services because obviously, as you probably are aware, AWS has hundreds of services, more than 200. Therefore, knowing in deep all of them is very if not impossible.
Obviously, yeah. Yeah.
So that said, the specialist team usually have like a subset of these services, and we drill down into the solutions with our customers, with the service team, in order to bridge the gap between what's happening around the world with our customers and what our service team are building. Because one thing that I discovered that is very true before, when I was customer, obviously I heard very often in AWS that majority of our features are created because our customer are asking for that, and therefore we are analyzing them and trying to gather stories, requirements, and bring the customer alongside the journey when we are building these features.
Okay, that's awesome. Thank you. Like, could you give me like a brief explanation of what microservices actually look like? I mean, people are actually using like monolithic frameworks such as Spring Boot or Ruby on Rails. And how does the thinking and the mental model change when it comes to microservices?
Usually, when you think about microservices, you start to look into a complex system that, let's say, you want to have multiple teams working together, but without stepping in each other's toes. Very often, people think that either you go with microservices or monolith or whatever. For me, it really depends from the context. I'm not, let's say, a fan of let's take this architecture because I don't know Netflix is doing that or AWS is doing that, whatever it is. That for me is your context that is leading towards the right approach, and the architecture is a way to enable your system to be expressed in a certain way. Sometimes having a modular monolith or a monolith is more than enough for what you need to build, and sometimes you need to go on the other spectrum of the modularity. Then you go towards microservices. However, when I think about microservice, the question that usually everyone has is how micro is a microservice? And I don't believe there is, let's say, a way to define it that I can tell you in a pragmatic fashion, okay, 100 lines of code is a microservice. It really boils down on a lot of shades of gray that you need to think about when you're designing microservices. For me, personally, I usually to take into account few things. First of all, what I need to express in a system. Secondly, how big are the company that I'm working with? And also how, let's say, how is the rate of change on code and additional features. And those are three heuristics that I use often because it helps me to, let's say, find the right boundaries for a potential microservice. Obviously, if you have an existing system, I have other additional insights that help because I can check on the APIs, I can check on the volumetric, I can check the communication between systems. Sometimes if I look into a monolith, you can start to see in the code, okay, so these functions are calling each other together or retrieving the same information from a database. So we need to be careful here. Can we split them? Should we need to collocate them? And I think there is an heuristic that very often is overlooked and either people don't know or are not too familiar with, or the ideas of integrators and disintegrators. It was coming from Neil Ford and Mark Richards, where they describe basically the idea of that there isn't only one way to slice an application. Well, if I remember well, in a conference they were talking about payment methods. If you think about that, potentially the first thing that people would think is, okay, I create a service per payment method. But the reality is, you could simplify your life if it's just one thing taking care about that, where in reality you can have maybe credit card that changes more often because you have multiple countries have different payment gateway that could require a lot of changes. That is a microservice, while PayPal integration or other ways, Stripe integrations or bank transfer, whatever is more, let's say, stable, that when it's implemented, you keep the lights on. You can have a single microservice with all of them. And then in the case that you need to split it up further, you can do later on. You don't have to immediately aggressively go towards a super granular and modular fashion. Sometimes you don't need that, and you simplify also your life in thinking in this way.
Yeah, that's an interesting point, because you mentioned like granularity, and like another important attribute that people often assign to microservices architectures is that of scalability.
Yeah.
And I was just wondering, like, how much of that scalability is actually scalability in technical terms, like in traffic or in unexpected traffic spikes, and how much of that is actually scaling in people? How much does like a microservice architecture change the way developers are working with the code?
Personally, I think, at least in my experience, there are some, let's say, systems that require heavy scalability on infrastructure, but I cannot say there are no millions. The majority of, let's say, of the system can handle easily what you can find in the cloud or also on-prem. So it's not that you need always to scale horizontally. Sometimes you can scale just vertically, and it's more than enough. Although I believe the organizational structures is one of the key aspects for why you would embrace microservices or distributed system in general, because if you think about that, in reality, a lot of the let's say friction that arises in a monolith is because either you have spaghetti code or the cognitive load is too high. If you onboard a new person, it takes forever because before they are productive. If you want to make a small change, you need to go through a battle testing of billion of load testing, integration testing, unit testing, and you know it. And therefore, that means also that there is a lot of time spent in stuff that maybe are not even affected. When you look into microservices, although you can say, okay, if I split in a certain way my application and I change just a portion of the system, then I need to test just that portion of the system because the rest is untouched. And therefore, you have some cascade benefit that are going over the simple, I'm organizing the company in a certain way, or I'm defining the code in a certain way. You have a faster onboarding. You can obviously have less tests that you need to run when you change something. If something fails, potentially fails in isolation, depends how you design things. You can have techniques like stale data to serve, or let's say gracefully hide specific features. So there are plenty of these techniques that you can think about. But I think the beauty of the distributed system in general, that enables you to have more nuances on how to express yourself architecturally speaking on design phase, because you decide, obviously there are some pitfalls, and we are going to touch in a second probably, but the idea is that you can express yourself and say, okay, so this part can be synchronous, but this other part doesn't have to, so I can work in batches, reducing the cost, using event-driven architecture and stuff like that. It depends from the use case and the workload, obviously, but you have more nuances that before in a monolith, you are basically everything. I call this function, I call that class. And sometimes after, let's say, few years, usually you dilute the quality of your code, mainly because people are, not because they are bad, but maybe they have a bad day sometimes, or they are changing team, or they are leaving the company, and then you have new people jumping in. So, there are plenty of things that, let's say, can help you to challenge a bit the way how the code base is written. And even when you want to change a pattern, for instance, you need to, I remember back in the days, you were doing a lot of meetings with the senior tech leaders or the architect, etc., in order to agree on a pattern, because then you need to roll it out across the entire code base, not just on your area. While with microservices, you have a bit more flexibility on how you do certain things, especially if it's something that is related to your bounded context and not affecting the entire system. I think the main pitfalls. Oh yeah, so go ahead.
Sorry, go ahead.
The main pitfalls, in my opinion, in what we are seeing with microservices is the additional complexity you need to think about. So now you need to trust more the people in the trenches, so developers. You need to decentralize not only the organization but also the decision making to a certain extent. You need to think about let's say accepting certain changes that are not honestly affecting the stability of the system and might improve even the certain KPIs on your system. So it's a mindset shift that you need to embrace, and it's not always easy, especially if you have a very hierarchical company where you need to work more in a federated fashion instead of a hierarchical one. And therefore, this is not something an easy task, and many people might feel that they are cut off from their work, but instead their job is just changing and shifting towards, let's say, a different approach, but with the same importance.
So that means, like, from a organizational point of view, it's like the mind shift that we have seen maybe from waterfall to agile in some way. It's about decentralization. It's about giving responsibility to like smaller groups of people. They are self-organizing. That would all apply to microservices as well. Technically speaking, you mentioned it. You have like an application, whether it's a application that's already done or you're inventing a new one, and you slice those into components. And I don't know what the right metric is. Maybe it's the 100 lines, maybe it's 200 lines. In the end, it doesn't matter. But that's a lot of like small components, a lot of them. And it's fine for developers if they are only working on that one component, on that one microservices. But how does it actually look in practice? Because at some point in time, as a developer, I might want to see the whole application running to see the impact of my changes. How would I do that? How are development environments usually set up to work with microservices? Is that all in the cloud? Is that partly in the cloud? How do I synchronize actually?
So it depends also from the technology you use. If you use containers, majority of the time you can test a chunk of your application, replicating it on your laptop. It's not always, if you then deploy on the cloud, then you will have some slightly different behaviors. Especially depends how you let's say handle the platform in general, but that could be a good starting point. I think nowadays if you work with serverless, there is this mindset shift on top of from monolith to microservices, where you test locally a bunch of solution, a part of the solution, like I don't know the code that is writing into a database or into a queue, wherever. But then you can test quickly on the cloud. And the benefit of doing that is that there are certain situations that I've seen that it works maybe in an environment, but it doesn't work in another one because you don't have the right permissions, or there was a change from the platform team that you weren't aware of. There is latency attached to network, obviously, because the more chatty is your service, the more latency you might find. And therefore, there are certain, let's say, important details that will impact a certain decision that you have. Therefore, definitely unit testing, potentially integration testing, you can do easily into locally into your laptop. But it's very important to not stay away too much from the deployment. Therefore, an investment that is also one of the, if you want pitfalls for the companies using microservices, there are investment around standardization, guardrails, and especially on CI/CD and creating automation around the let's say the system, the social technical system. Because the reality is, without that, if you are not capable to hit the ground running quickly and deploy faster in dev, pre-prod or prod, and then people start to find ways to cheat the system, right? So I was guilty of that for millions of times. And I think is unfair, because obviously the real solution is, let's invest time on streamline the deployment of our system. I think that is extremely important. And when I was VP of architecture in the Zone, that is the live sports streaming platform, where before joining AWS, one thing we were doing pretty well was spending time on the CI/CD when start to slow down. When we see that takes over 10, 15 minutes, there were, let's say, tasks for developers, for each team, to improve their own pipeline. Because if you don't have a fast feedback loop as a developer, it's a disaster. You cannot really shine you're basically minimizing the benefit of distributed system. That one of them is hitting the production faster, testing it sometimes in production if needed, using canary release, blue-green deployment for portion of the system, feature flags if needed. So there are a lot of things that you can do that will make your system more stable and developer more confident. I used to say the safe net for developers when I talk about canary release and blue-green deployment, and I believe these are great perks that you have. But if you don't invest on your CI/CD, you're pretty much minimizing the impact of these solutions.
So I think like a large chunk of the mental load, of the cognitive load of architecturing microservices is like the art of orchestrating or composition of all these kind of things. So the overarching question here is, how do all these micro components work together? Could you like briefly explain how that works in like a high level overview?
Yeah. So first of all, I want to stress out one thing. The micro world doesn't mean that it has to be small. Okay, so that is a very important thing. I wrote a few articles, even in AWS, because very often, when you think about a Lambda function, that is a piece of compute that is managed by AWS, where we run a sandbox with your code. Many people, for instance, if you create a REST API, they use one function per CRUD verb. So one for create, one for update, one for delete. That might be a case, but it's not always the case, right? So I think you need to understand how micro is micro. Therefore, it's very important, in my opinion, that we don't think immediately, microservices is equal to having bazillion of services. You can have more coarse-grained services, and it's absolutely fine. So that is one thing I want to stress out. Now, architecturally speaking, when I was looking into how, let's say, the microservices were built and communicate inside the Zone, I think it wasn't too crazy in the way how we were communicating, in terms that there were some parts that needed to be synchronous due to a quick response towards the user, because our primary idea was that one. And therefore, our, let's say, duty was looking into the communication across bundle context. The problem was very often people start to look into all the details inside the bundle context. But that is where, honestly, developers can start to use that part as a playground for learning best what would work and what doesn't. As an architect, usually you start to ask the right question in order to put, let's say, the right emphasis in specific characteristics you would like to express. But for me, if I was capable to use synchronous APIs for communicating fast towards the user, and asynchronous API were possible for everything that was at the edge of my architecture. So integrating with the CRM, integrating with the subscription system, integrating with other parts, then I have a very interesting approach, because I can take the heat of my APIs request at the entry point of my architecture, while I can keep simpler to test and to manage, and also cheaper the part that is inside my architecture towards the SaaS product that I'm using. And I think that helped a ton for minimizing, let's say, the work, but also asking the developers to be part of the solution. Because the problem is very often I'm still seeing some organization that they tend to centralize everything to the architects, that they are a bit detached from what's happening in reality, because the moment you design something and then when it hits production, I can guarantee you that there is a discrepancy of what you design and what is in production. Therefore, in the only solution as I can see that is having, let's say, a strict relation with the developers or the lead developers if the organization is really big, and in empowering them to take certain decisions, because they are in the best position compared sometimes to architects for doing that. As architecture team, our role, in my opinion, is looking holistically on the balancing the system to make sure that certain principles remains. And then it's obvious that sometimes, you have the developers that come up with some ideas. Remember back in the days, there were developers saying, oh yeah, we should use Golang instead of Node.js because we need to do this API. That, technically speaking, yes, you can do that, but what's the benefit of rewriting a service just because you want to learn a new language? The reality is, you write a service in a low-level language if it's more than, if you need more than writing on a database and returning a response to a user, because even there the SLAs were extremely generous, so you didn't have the problem of latency or whatever it is. It was just an exercise for the developers to be more proficient in something, but unfortunately for them, they were in a domain or an area of the application that honestly using a lower language didn't add any value to the user or for the system itself. So I think is balancing. It is a balancing act that the architects needs to do overall when they deal with these kind of systems.
Yeah, I mean that's basically CV-driven development. Then, if you're writing for the sake of just using another language. But I want to quickly circle back to the mental model or mental model difference between like working in a monolithic framework versus working on a microservices architecture. So all of that you mentioned, I really don't have to care if I'm working in like a full stack web framework, because like if I want to call some other functionality, I have it immediately in my IDE because I'm working in a monolithic code base, right? Whereas in microservices, I need to rely on like open API specifications to call another service or something like that. I mean, there are solutions, but they have to be taken care of like individual. So would you say that's impossible to have something like Ruby on Rails for microservice architecture? Is there like a microservice/serverless framework? Will that ever happen?
I don't think it's even the goal. To be honest, there are certain situations that you really need to have, let's say, a different approach for the API or a different approach for the system. Therefore, what I was saying at the beginning, you really want to have, let's say, the possibility to express yourself in a certain way in a distributed system. I don't think that will compromise the consistency inside the system. There are certain situations like you described. I have seen several customers asking, okay, should we have like multiple API gateways, or do we have like a single API gateway for everything? And my answer is, again, it depends from the state of your life cycle. If you are migrating tomorrow from a monolith to microservices, I personally would go with multiple API gateways, because you are doing premature abstractions on top of that without really understand the real needs of everything. When you have enough microservices built, you have enough information that you built to standardize that in a single entry point. Then we'll simplify the OpenAPI approach, and then basically the complexity lies into the governance part that is often overlooked, and it's where, in my opinion, we need to invest time, especially when you are at a certain level of maturity, to make faster the onboarding for new teams, as well as streamline certain processes that raise friction, where friction can be, okay, so now in order to upload my new OpenAPI schema, it takes, I don't know, 1 hour because I have to open a ticket. I need someone that reviews that or stuff like that, while it should be automated, and we should figure out how to put in this automation all the checks that I need, or the guardrails that I need in order to make sure that it's not a human being doing that, but or wait for a week because I need to cut a ticket to the platform team. But it's an automatic approach that helps people to do that. I don't think, there are merits obviously on Ruby on Rails, like for any other, let's say, streamline approach that thought properly on everything. But I think the key difference here is that the way how I can express certain things on microservices is not easily replicable on a monolith, because at the end of the day, it's just I call this function, this method, and so on, and then I have maybe one database that contains everything. All these nuances enables you to scale organizational and also on expressing yourself properly. For instance, very often, I have certain solution that in a monolith, I would need to do everything synchronous, while in a distributed system, I can decide if a part is synchronous and another part is not and is more asynchronous. And that opens up a lot of opportunities that before I didn't have.
Yeah, so that's basically the same for like things like event sourcing, CQRS. People were trying to build frameworks around that and just realized, okay, that's always more or less a custom-made solution then. So, sorry, go ahead.
Yeah, no, I'm fully agree with you. I think there are certain solutions that out there that could fit your context, but then you need to decorate, adding more information. Now, I believe at the moment we are trying to reach certain level of abstractions. If you think, let's say, we move from racks that you can touch and you can order your server, all your hardware, whatever. We move to VMs, then containers, and serverless. So we have a variety of a spectrum of abstraction that you can cherry pick. And the other beauty, in my opinion, of distributed system, you don't have to standardize in a single thing. You can choose what works best for you. If you have, like, for instance, a cron job that is running at midnight in order to do certain processing, but then probably serverless fits better the bill because you just call that thing at midnight and you pay for what you use, then disappear. It doesn't pay for anything till the next day. While if you have a VM or a container, you have something that is up and running there for 24/7 because at the end, you are not going to shut it down completely. You might have something that is there, let's say, silent, waiting for being triggered or whatever. So I think there are some, and at the same time, if you have like to, I don't know, manage a massive data set with terabyte of data, you're probably looking into, I don't know, Kubernetes or a container solution that will enable you to leverage the GPUs and other things. So again, because we have this possibility to identify workload characteristics and apply the right infrastructure alongside the right architecture, I think our job becomes now having a broad understanding of what's available out there and trying to not play only the economy of scale game where we just use one solution to feed them all, because inevitably there are some teams that won't be too happy on dealing, or we add complexity on certain teams because the rest, I don't know, 70% of the teams are happy. So we need, I think, to have a certain level of flexibility also on deciding the path that we are taking.
Yeah, absolutely. So we touched basically like the fundamentals of microservices and serverless as much as you can in like 28 minutes now. But if I was like a company with an engineering team, and if I was to decide, is it time for me to switch to a microservices architecture or not? Like, based from your experience with AWS customers, what is the perfect situation in which people might decide, okay, let's get from monolith to microservices?
I think everything boils down, and this is a question, to be honest, that I ask often when I'm at the beginning of a conversation with a customer that they are thinking about that. So what are the drivers? And very often, if it's just, we need to change technology because it's obsolete. Okay, so what does your system does? So there are certain, for instance, I remember a customer that has an internal CRM that they built that was used for very specific things, for purchase order, stuff like that. That was very bespoke for the company. And so, okay, so yeah, you can move to microservices. What's the benefit? I mean, how often do you change this code base? And they said like once a year, probably less. So there is low value in doing something like that. While I believe if you have, let's say, in certain areas where I don't know, you have like a competitive edge if you move to microservices due to the fact that I don't know, there is a new technology that requires to let's say change and evolve very quickly. If you think about the AI thing. Integrating in a microservice fashion might help a ton because it's changing basically. If you think about the last 12 months, I don't know how many innovation things happen during this period. So having something more modular can help you to plug easily compared to a monolith that would then be required to test all the other things and do all the exercise on scaling horizontally and vertically, and sometimes slowing down on scaling horizontally. So I believe that there are certain situations where certain drivers that will help you to decide better to move to microservices. But I want to stress out the fact that I'm not pro distributed system and against monolith. I'm quite agnostic on that. So if for instance, if I have a code base that I need to throw away after a month because this event is 1 month long and then I don't need anymore, write a monolith and write it even with poor test coverage, because at the end of the day, it has to stay up for 1 month. But if you need to create a system that is, I don't know, a credit card system that will stick around for 10 years, you want to write today and you're asking yourself, shall we extend our monolith? We go with microservices, but then probably we need to discuss what are the how do you expect to evolve, how many people are going to work into that, and very probably you are going to end up with microservices as a potential solution or a modular monolith, but probably you are not going to extend the monolith that you already have. So I think, to be honest, there is a level of pragmatism that we need to take. I don't believe anymore, probably because I'm old, on let's say, because Netflix is doing that or Spotify is doing that, or we need to do that. These are contexts that are completely different from 90% of the companies, if not more. So we need to be aware that microservices bring some benefit, but has the pitfall and investment that required to have a platform team, to have a governance to think about, to have, I usually define them as living system, because it's like having kids. You need to nurture them. You need to look into how they behave when you provide something to them and stuff like that, that makes the life sometimes more complicated than having a monolith. So that's why I'm saying, if it's worth it, go with the distributed system. Otherwise, even a monolith, a well-written monolith or a modular monolith is more than enough.
It's more than enough. Yeah, totally. So I liked it how you touched it, like basically from an organizational and like a business point of view. That should be the driver, not the technical aspects of that so much. Especially like, again, like, for most of the companies, especially when it comes to like internal CRM systems and the like, it's not that you need to scale for like unexpected traffic bumps or something like that. You know your workloads. But the other thing that you mentioned I found very interesting is if you want to have like a quick time to market for adding new features, I think that's one of the benefits that you can have with serverless.
Completely. And bear in mind, they are not mutually exclusive. So you can have a monolith and maybe you want to try a specific feature quickly, and you spin up, let's say, a microservice or a bunch of microservices for testing out. And then if you're happy, you can merge into your monolith if you want to do that. In general, I think there are a lot of benefits, and probably, it's 10 years that I'm working with microservices on the back end. So it's been a while. So now for me, it becomes very natural thinking in that way. But I totally understand. I'm helping customers, for instance, to understand the boundaries. I think that the part that people struggle the most is that one, because we were talking about microservice. So people mind immediately goes, okay, I need to write a small chunk of code, a lot of services connected. But then when you look into, if you take a step back and you look into running, I don't know, an event storming session, where you start to look into your business needs, you start to look how your customer are interacting with your system, then you start to see, okay, so probably it's not that fine grain as expected. Can I stay more coarse grain, or maybe this area requires more fine grain approach, while these other three can be more coarse grain? Because you can always, if you have good engineers, you can always split it up later on. It doesn't have to be perfect day one. It's something that it's easier actually to split up, let's say, a modular monolith than merging multiple microservices into something bigger, because there are different code style, there are different decisions made by different teams, and so on and so forth. So personally, I think teams should be aware and should be train on, let's say, I get that the microservice might seem cool, but at the end of the day, we're not writing code for the sake of writing code. We are paid for writing code to generate a value for customers. And unless we don't start to think about our customers first, then whatever technology we pick, it might be not the right fit for what we are trying to achieve.
That was a great arc, because like, speaking of customers, we haven't touched the user facing part of that.
Yeah.
I mean, that's basically, we talked about microservices, like batch jobs, synchronous workflows, asynchronous workflows, connecting to databases and stuff. So that's all backend. So how does like front end come into play? So what is the concept of micro front end in that context?
The idea is similar, right? So when I started to look into this approach before the name Microfrontends came into play, because I was doing that a year before, I was thinking, okay, so I need, in the zone, we were in a very unique situation. So we were growing fast. We had to onboard roughly 1 or 2 teams every other week. So we moved from tens of people to hundreds of people in a couple of years, spread across Europe, and I need to enable them to work in parallel. So on backend, microservices, fine, we know that it works. Obviously, it's not straightforward, but it can work. But on the front end, the only solution back in the days was a monolith. And I know for experience, because I work luckily in large, obviously not, I don't know, Gmail, but large enough code bases for front end, where at some point you reach a point that becomes extremely slow to evolve the application, and you can be as fast as you want on the API, but the front end cannot cope up. And therefore, I came up with taking the principles of microservices, apply to the front end, and trying to, let's say, mold everything together in a way that enables people to not have a one-to-one relation between microservice and front end, because I don't believe is always healthy, but having the possibility to have a cross-functional teams that is capable to have a boundary or an area of the system that can work independently, and try to stay coarse grain enough that maybe a team of front end can have I don't know, multiple APIs to use, and that honestly provide us a lot of benefits on performance, on also on the way how we were building stuff, because we were way faster, because we have multiple teams working in parallel. They can deploy independently. They can test their own API. There is no, we reduce drastically the external dependencies between team and the communication across different dev centers. So the approach was literally looking from how the user were interacting in the system and splitting up in a way that doesn't compromise the user experience. An example I can make is, for instance, if you think about a subscription service, you have usually a landing page where you understand what the service is about. Then you have a path that you can either be an existing user that needs to sign in on a new device that they bought, And this is the onboarding for the existing user. But then you have an onboarding for a non-existing user, so a new user that is basically need to sign up, provide a payment method and stuff like that. So if you start to look into this logic, there are already some stuff that can be split it, because if I'm an existing user, I'm not going to go on the sign up part. If I'm a new user, I'm not going to do sign in. And if you start to load things dynamically in this way, that means also that the payment part that usually has a lot of SDK that you need to integrate with, I don't know, Stripe, PayPal, all the different payment methods that you have, won't be loaded for existing users, and it won't be loaded when you are already authenticated. So that means we are starting to have great benefit on performance, because I just load enough that is needed for the user to accomplish a specific task. Because very often we think holistically, oh, the user is going in every single page. That is not true. I don't go in every page on Amazon.com when I buy something. I go to the home page, I search for, I don't know, laptop, and then I will browse through the laptops, period. It's very rare that I go into my account with other things. So if we can show, but not load in memory this stuff, now becomes extremely interesting, because then I can divide my application in a more modular fashion or more granular fashion, depends from how you want to handle this. But that enables DAZN at the beginning, and other companies like Zalando, for instance, was another big brand in Germany that was an e-commerce doing that. But nowadays it's used by amazing companies like PayPal. Discussed about that 7 years ago. Formula One, for instance, I was on the stage of reInvent, this is the AWS conference in Las Vegas, with one of their architects. So the new website of Formula1.com is fully Microfrontends, and I helped them to design this. So there are a lot of companies, though the major retailers, for instance, in the UK, are using this approach. So worldwide nowadays, it became quite common in banks, in financial institutions, because it simplifies. It basically you have the benefit of microservices, but on front end. And what I witnessed is that usually a modernization for a company that is moving from monolith to distributed system end to end, it takes roughly half of the time with the front end over the back end, for a simple reason: there is no data to move. I can use Microfrontends with a monolith backend, and it's absolutely fine, because the API is mine.
As long as the API is defined properly, that's fine. So I just want to make that a bit more tangible, like to actually see what's happening there. So let's take the example of an online shop. So I go to the website, I go to my account, click my order history, then I go back to the home page, then I search for a laptop. Then I click the laptop, and then I click add to basket. So does it mean that if it was implemented in a micro front end architecture, does that mean that I could have like a team working only on the checkout part, and a team that only works on my account settings part, and a team that only works on like the search results part? Because as a user, it's a monolithic app for me.
That's exactly what it means. So, for instance, if you take the search, depends from the size of the company. Obviously, a company like Amazon.com, for instance, you have a multitude of teams, definitely quite an edge case. So therefore, it can be more granular because the complexity of handling just search or the header is by far greater than any other company probably in the world. But if you look into, for instance, my account, I think is a good one. There you have a multiple bounded context, right? Multiple subdomains, because you can have the payment part. You want to change the credit card, for instance, or apply a gift card or whatever. You can have like the user details. You can have the orders history. So those are usually in different domains. And therefore, in the Microfrontends part, it could be that the team responsible for orders and the team responsible for my account, for payment and so on, provides Microfrontends that will be stitched together in order to create a unique experience. So they can be responsible end-to-end on how it looks like the payment without leaking the knowledge to another team. Because as you can imagine, if I leak the knowledge to another team, it means friction arises across the team. So now if I have another team doing the front end, suddenly I need to wait for them to make the change, and maybe they have other changes to make for another part of the system, so it becomes quite complicated. With that said, I believe that the challenge is very often people thinks that mistakenly that microfrontends are equal to components in front end, but they are not, because a component has by design the idea of abstracting and reducing the abstracting capabilities and reducing the duplication, while microfrontend that it doesn't have that requirement. The requirement is reaching fast flow for a team and creating independent team that can move faster. Therefore, a component will never be a microfrontend. If you design your microfrontends application with the size of components, it's going to fail miserably. It's like the big ball of mud of microservices, right? So, and that's why I believe it's important always to spend time on designing properly, understand what you need to express. Backend and frontend doesn't matter, and trying to spend the right amount of time for understanding how to slice the system, because when it's sliced too granular, the risk that you have is that then you blame architecture, but the reality is the design, the problem, not the architecture itself.
Yeah. So you mentioned probably just the header at Amazon.com could be more complex than anywhere else in the world. I totally get that, because it's also the largest online shop out there. But I'm just thinking of other examples where you have strict boundaries between things. And one that came up to my mind is, of course, the AWS console, because there you have hundreds of services, all with their own requirements for UI. So is that how it's built internally?
So internally, I don't have visibility too much about that team, because it's an engineering team, multiple engineering teams actually. But basically, every single team is responsible for their UI and in the console. They have an overarching design system that we open sourced, I think, a couple of years ago, that people can use also for building their own UI if they want. But basically, the idea is that every team is building their own part, and therefore it's a form of microfrontends. So especially if you think about the entry point of the dashboard where you have multiple widgets, that definitely is an approach that basically multiple teams are building their own solution. For instance, the team responsible for Cost Explorer, for instance, will build a UI for that, and the team responsible for just making it up, the CloudWatch for I don't know, the logs or other alarms that you set, it will build their own UI, and then everything will stitch together. So there is a team, a sort of platform team, usually that takes care about let's say collecting and gathering these things all together and generating an harmonious experience.
I like the term stitching together all that stuff, because that's again probably the most big or the biggest hurdle when it comes to learning all of that. We already figured out there might not ever be a framework for serverless. And if I go with serverless and micro front ends, I lose the Django toolbar app where I have centralized SQL logging and stuff. I need to do that in terms of governance, tracking, tracing, logging on my own. I need to take care that all of my API endpoints are specified. And I might even need to launch, like you mentioned, a design framework or design template to ensure that all of my micro front ends eventually look the same.
Yes.
So as opposed to just go to Ruby on Rails, hit download, open it in the IDE, which is a great way to start if you're just exploring things. How would people learn about microservices? How can you get your hands dirty as a developer wanting to learn more about it?
I think first of all, it's a journey, right? So even if I think, for instance, serverless, there are some abstractions. For instance, there is an open source library called Power Tools that is available in multiple languages that abstract basically the best practice for integrating with observability. So if you're doing distributed tracing, if you're doing logs, structured logs, it takes care for you to do this part, create segments across inside your code, so you can say, okay, this query takes 5 seconds. You can see easily inside the observability dashboards that we have. So there are abstraction in microservices as well. I think
so. That's the AWS Power Tools, right?
Exactly. So it's an open source product, the open source project that was created by DAZN, the company where I was working, and that was so much appreciated by AWS that was taking into account from them. So now there is a team taking care about Power Tools.
I love it.
Quite it's funny story.
Oh, I didn't know about the backstory, but that's really cool.
Yeah. So if you search on GitHub Power Tools DAZN, you will find the one that we were using.
Yeah, we put it also in the show notes.
Yeah, it's super fun. But the interesting part, it's if you want to start, is starting with some basic things. So start to think, okay, what is a portion of a service that can make sense to extract from my monolith? Or if I want to build something from scratch, okay, what could be a service that could make sense? But not thinking about the API design and how you divide in CRUD, but more deciding on, okay, so what are the capabilities of my system? Let's carve out a capability. So from this capability that I selected that I can start, how can I design it? How granular needs to be? How should I, and investing that time in understanding how granular needs to be this system. Because when you start to do, let's say, use the same pattern everywhere, I can guarantee you that there are some use cases that won't fit the bill. And therefore, you're going to regret certain decisions. While if you spend time looking at what you need to express and understand what the business wants, then it's easier to understand how to collocate code or not. And I think that is the first step. Then the getting familiar, obviously, with containers, that is, let's say, probably the lingua franca on microservices. And at the beginning, use the language that you are most in love with, or the one that you're most proficient with, and that will be more than enough. For instance, funny enough, I've seen a company went in love with Lambda functions, and they decided to do a custom runtime for COBOL because they were running in a mainframe.
Wow.
So those stories are real, right? So, and there is also a blog post, if I remember well, on AWS on this. But
we need to find it. I put it in the show notes as well. That's awesome.
But that's the thing. So the reality is it's not a technology challenge. It's a design challenge mainly. And then you do basically what you were doing before with less scope, in a better way, because you don't have to, let's say, go crazy with all the edge case. Oh, now we have to deal with this X, Y, Z. And then you can start to think about optimization, like should have like in memory, should have an external cache. What kind of cache can I use? So you start to enrich basically your design based on the volumetric, the SLA that you have, the architecture characteristics that you want to express and stuff like that. But that forces you to step back from the code. What I usually say is that in microservices, the code doesn't count as much in a monolith. You can write a very horrifying code, but if you have a strong design and a strong foundation, that microservice will land way more than having the most beautiful code ever. Then obviously there are certain situations that having a well-designed code base can even help further, because you can have portability in your code. You can move between different type of infrastructure from a Lambda to container and vice versa very easily. And there are companies that do that in order to optimize their cost bill, or but I don't know if they understand that there is a point in time that first the workload will be like that, but then using a Lambda will make more sense. So let's go quick and build in containers and then move to Lambda when I'm feeling more comfortable with. So there are plenty of situations, or vice versa, because we have seen also that. So there are plenty of situations that will help you to, let's say, take the right decision, but you need to spend time investigating what you need to express.
Absolutely. So, like in the whole world of microservices, there is a lot of it depends.
Yeah.
And probably that's also the reason why the cloud primitives that AWS offers are so granular. Like they are so granular configurable, they are so small, they are actually microservices themselves. Um, and of course, like for solo developers or smaller teams, things like Vercel might feel like attractive because they bundle all of those very granular primitives to something bigger that might hit like 80% of use cases in smaller projects. So
Correct.
what's your take on those?
Yeah, absolutely. I mean, there are plenty of companies out there that are doing an outstanding job on building the abstraction on top of primitives. Vercel is an example, for instance. Netlify could be another one. There are plenty out there that are doing amazing stuff with that. And that's also the beauty of what we do. Obviously, with abstraction, you take also opinions or way to think that might or might not align with what you do. So for me, I remember at the beginning when we were thinking in the zone what kind of programming language we wanted. So Netflix that time was doing pick whatever language you want. They regretted a few years later. But in our cases was you have two choices. Either is Node or is Go. But Go is used only for low-level APIs that require throughput and require a certain level of computation. Otherwise, it's Node. And the reason being is you can say, okay, you can pick Java, pick whatever framework in Java you want, but then, okay, is Scala a potential solution? And if is Scala a potential solution, can I use Akka? And Akka uses an architecture is completely different compared to what I would do with Spring Boot, right? So there are, let's say, when you bring a language, when you bring a solution into the house, it's not just the technology part that matters, it's the opinions put inside the solution, this abstraction that matters most, because it will force you to deal in different ways. Similar for, I bring Elixir, and therefore I need to have people that think like Elixir design with the actor model, while I want to use an MVC, and then maybe a C# monolith will be more than enough, or a Java monolith. So I think it's important that you don't only think about the technology aspect, the programming language or the hype framework, but you understand also, okay, what I'm buying when I select Vercel, Netlify, whatever, what I'm buying when I go with Spring Boot. Do I have everything that I need? Is it aligned with what our, let's say, skill set inside the organization is aligned with how we think things? Because there are companies that are doing everything functional and therefore they want to go with F#, for instance, while there are other companies that, or Haskell, there are other companies that they love to go more imperative and therefore maybe they want to go with Java. Some companies have a hybrid and they put a bit of reactive programming inside that. So it's there are a lot of flavors, but flavors means also that you're bringing some thought by other people inside the organization, and you need to make sure that it doesn't reside only with you, because if then we'll expand across multiple teams and they struggle to pick it up, then we have a problem.
Yeah, so that's basically a great way to put it. Like AWS as a service layer is like unopinionated because it provides those smaller primitives, and what's built on top of that can be opinionated and might or might not fit your particular use case.
Absolutely.
Yeah, very cool. So one last thing is about your book. Like I think there is a new version of it, like published at the end of the year.
Yes.
So what prerequisites do I need to know to learn about microfrontends from your book? What should I learn first before reading yours?
So the book is not covering, it's not a traditional book where you will see, okay, this is the example of React, this is the example of Angular, whatever it is. It's spanning across principle of microfrontends, starting from microservices and say, okay, this is how you apply in microfrontends. Then moving into pattern that I identified. There is a chapter on anti-patterns. There is a chapter around deployment, CI/CD, and how you should think about that, discoverability, canary release, blue-green deployment, stuff like that. There are obviously an overview of frameworks where I'm not showing every single framework in action. I choose a selection, but I categorize them and say, okay, those are for server-side rendering, those are for client-side rendering, pick these if these are your use case, and pick that if this is your use case. I try to provide a table for each framework to say, this is more developer experience friendly, this one is extremely opinionated, or so I spend a lot of time over the years trying to categorize things and being as agnostic as possible, because as an architect, I think obviously I have my opinions, I have my preferences, but at the same time, I totally understand that you can reach similar or better, let's say, outcomes and outputs with different approaches. Therefore, I try to take a step back and looking objectively of things, or as much as a human being can do, obviously. And therefore, it's for tech leaders, it's for software architects, staff engineers, that someone that has to design and build this system. There are some stuff more vertical for developers. In this edition, I added a chapter on server-side rendering, showing how to build certain things with Vercel, with Astro, and other stuff. I share, so there will be links on my GitHub repo, but if you want to go on my GitHub repo, you can find already a few examples there on how to build microfrontends. And then obviously this is the part that is more agnostic. Then I have stuff that I created for AWS, where there is a prescriptive guidance that guide you on an overarching idea of how Microfrontends works, what are the challenges compared to a normal monolith, or the way how front-end people are doing, how to apply that in AWS and stuff like that. But the book, to be honest, is not like a bump up version. It's almost rewritten, because I basically killed 3 chapters and rewrite 7, and that did 6. Wow. So it was a 18-month work on testing out a few things with customer, because in the meantime I was in AWS, I was able to, compared to the first version, that there weren't many companies doing that, I was able to interact with internal teams and customers. So I reached roughly 100 of companies, for Fortune 500, that from Silicon Valley to New Zealand, helping them implementing Microfrontends. And therefore, the beauty of this is that it's way more opinionated than the first edition, because I see that things that I had a hunch that was working for a few companies, now I'm sure it's working. Now I'm 100% sure that what I'm preaching, luckily for me, 90% of what I was preaching in the first edition is still valid. But now I'm even more specific, adding heuristics, adding more suggestion that became clearer over the years when I'm starting to implement that with other customers.
Yeah, very, very good. So that's a tremendous value. And I love the fact that it's a book. Like in that time of like being TikTok and YouTube courses and that stuff all over the place. I love it that it's that tree. Perfect. Yeah. So, and one last thing, you mentioned you have a GitHub account where you, post like, examples and also like references in the book. What are other ways for people to reach out to you? Is it Twitter? Is it LinkedIn? What's your preferred way?
LinkedIn and X are the two, let's say, social that I foster the most. And then I started 2 years ago a YouTube channel where I discuss about technology in a cinematic fashion. Became quite passionate about cameras and let's say high quality videos, like certain creators are doing, and I'm applying these techniques into tech. So, for instance, I went to a few conferences and I tried to interview people, asking what they think about AI. A few months back, when I was in Boston, in London during the QCon, I basically discussed with other people about the perks of going to conferences, because I've heard many people saying that they don't go to conference because they can see everything on YouTube, but it's not true because there are some benefit on doing that. I describe how to build microfrontends. I describe some thought on tech communities, some tips on productivity. So I try to be as active as possible. I have my video podcast on microfrontends because many people are telling me, oh, but who are the companies doing microfrontends? So now I started the second season this month. So first episode is out, and now I have other 9 to publish. So a lot of activities around, let's say, helping the community to surface what I love, that are basically architecture in every shape or form. I have 2 newsletters that are, one is fortnightly, one is weekly, on architecture and microfrontends. So Dear Architects, if you heard about that, is probably the most popular one on software architecture, and then building microfrontends is the other one on microfrontends.
Yeah, perfect. We will put the links down in the show notes. That was a lot of like deep insights. Thank you so much, Luca. It was great talking to you.
Likewise, it was my pleasure being here.